Good morning, students. I hope you all remember that we have completed in our last class the applications of Bernoulli's theorem. Now today, the limitations of Bernoulli's theorem. Let us now discuss the limitations. Although Bernoulli's theorem is a very important theorem in fluid dynamics, but it suffers from a number of limitations. So let us first discuss what are the important limitations of Bernoulli's theorem. Right. So first limitation, you can write down. The first limitation is while deriving this theorem, we have considered the velocity of every particle of the liquid. The velocity of every particle of a liquid at a particular cross section is the same. Velocity of every particle of liquid in a particular cross section, you might have understood, in a particular cross section is the same, but actually it does not happen. Right? This is the first. Second point, in case of the derivation of the Bernoulli's theorem, we have not considered the viscous force or the viscous drag. Viscous drag. We have not considered the viscous force or the viscous drag, which is also here coming into account, which should be taken into account. So we have not considered the viscous force. Here you can say that we have discussed it. We have discussed Bernoulli's theorem in case of the non-viscous liquid, in which the viscous force is very small, but very small is there, but it is there. So we have not considered the viscous force in case of derivation of the Bernoulli's theorem. Third point, we have not considered any loss of energy. You might have understood, you might have felt it, that we have not considered any you can say loss of energy in this case. But actually, the kinetic energy has been lost in the form of the heat. Always it is there. And lastly, we can say, if the liquid is flowing through a curved path or a bent tube, suppose the liquid is flowing through a bent tube, then the energy due to the centrifugal force, bent tube. So if the liquid is flowing through a bent tube or the curved path, then the energy due to the centrifugal force must be taken into account. These are the four limitations. With this fluid dynamics, right? Fluid dynamics, Bernoulli's theorem, equation of continuity, that portion is over. Alright, this was the limitations of Bernoulli's theorem. Now, dear students, I want to move to our next topic. Limitations. After discussing these limitations of Bernoulli's theorem, I am moving to the next topic. This is the last topic of the fluid mechanics, that is surface tension. Let us now discuss the surface tension. Surface tension. Let us now see what is the meaning of the surface tension. What is actually the surface tension? You can write, it is the property of the liquid. It is the property of the liquid due to which the surface of the liquid tries to occupy the minimum possible area. The surface of the liquid tries to occupy the minimum possible area, and it acts like a stretched membrane. So it will occupy the minimum possible area and it will be acting as a stretched membrane. Mind this, due to this property of the surface tension, listen to me carefully. Due to this property of the surface tension only, the raindrops are spherical in shape. I just tell you, raindrops are spherical in shape. But mind this, small raindrops are always spherical in shape because small water drop or the raindrop, they are spherical in shape because sphere has the minimum area for a particular amount of the liquid. The sphere is that geometrical figure which has the minimum possible area. So it will have the spherical shape. But if the large drop is there, okay, if a large drop is there, it will be somehow like this. It will be a bit like this. It is the oval shape. Why? Because in this case, its weight will be dominating over the surface tension. Due to the weight, there is a flattening in it. Followed? So, surface tension is this. This is the property of the surface tension. Due to the property of the surface tension, the liquid surface always tries to occupy the minimum possible area. I hope you all got my point. Okay. So, in this surface tension, in this chapter on the surface tension, first I want to discuss how this surface tension is measured. How to measure the surface tension. Try to follow me. Suppose it is an imaginary line. So you can write surface tension is measured as the force per unit. Surface tension is measured as the force per unit length of an imaginary line. Force per unit length of an imaginary line. It is measured as the force per unit length of an imaginary line drawn on the surface of the liquid. Force per unit length of an imaginary line drawn on the surface of the liquid. Like this. See. Look, I draw the figure in this way. Try to follow me first. The figure has been drawn like this. Look, I hope you can see very easily. This is a surface here. Very clearly, it is a surface. मैं थोड़ा सा इसको clear कर दूं. It is the surface, liquid surface. This liquid surface here, dot, liquid surface. इस पर I have drawn a line of length L on which, on both sides, from both sides at right angle, the forces are acting. See, so that it will try to shrink the surface. It will be trying to occupy the minimum possible area. So forces are acting on both the sides of the line. It's an imaginary case. This line is an imaginary line of length L. And suppose the total force which is acting on both the sides of this line is F. Then the surface tension I can say T is equal to F by L. Surface tension T is equal to F by L. Force per unit length of an imaginary line drawn on the surface of the liquid. This is the force per unit length of an imaginary line. In this way it is drawn. This is the surface tension. Then we can say F is equal to how much? Twice TL. Look, it is the, F is equal to T into L. Force is equal to how much? Surface tension into length. Obviously, unit of surface tension, ST stands for surface tension, will be definitely Newton per meter. Dimension you can very easily find out. That is not at all a problem. So, unit of surface tension is this. When I am discussing this surface tension, I want to discuss between A a small thing. This is, I want to discuss between a drop and a bubble. If I ask you what is the difference between a drop and a bubble? Drop and a bubble. Okay. Drop means inside this liquid is there. Suppose water drop में क्या होगा? अंदर में लिक्विड होगा. Try to understand the property. इसके अंदर में लिक्विड होगा. तो surface tension is a surface property. It will always be acting along the free surface. I'm talking about the free surface. Now you will ask me, what is the meaning of free surface? Free surface का मतलब होता है the surface which is in contact with the air. The surface which is in contact with the air is called the free surface. Okay? So, in case of the drop, one free surface. Okay? In case of the bubble, there are two free surfaces. Why? Because inside the bubble also there is air. So, in case of the bubble, there are two free surfaces minus. In case of the drop, only one free surface. In case of the bubble, there are two free surfaces. Be careful. Two free surfaces. One is inside, another is outside. इसलिए क्या होगा? यहाँ पर surface tension का force जो होगा, इसके तुलना में यहाँ पे force double हो जाएगा. यहाँ पर force हो जाएगा, it will be taken as twice here. Because surface tension will be taken as double in both the surfaces. And here, it will be taken as here 2 only T12. Obviously, L का वैल्यू अब तुम क्या बोलोगे? L तो डिपेंड करता है, circumference हो सकता है सर्कुलर क्रॉस सेक्शन के लिए. तो anyway, the force of surface tension will be doubled in this case because of there are two free surfaces. Mind this is the difference between a drop and a bubble. I hope all of you got the difference between a drop and the bubble. It's very simple that in case of the drop, there is only one free surface, but in case of the bubble, there are the two free surfaces. In the next class, I will continue.